Hello everyone, my name is Julie and my partner is Seth.
Hello.
Today we're gonna present the introduction to the simulation.
Now, when we're looking at simulation, we can see that there are three common types of simulation. We have discrete event simulation, continuous simulation, and lastly, Monte Carlo simulation, which basically includes the discrete and continuous simulation under its umbrella. Now, discrete event and continuous simulation are somewhat similar with three very different characteristics. The time variable is in accordance with its name, with the discrete event having discrete numbers as time variables, and time variables for the continuous simulation being continuous or any real number. The state variables for continuous are also continuous, while the discrete event has the option of continuous or discrete state variables. And lastly, the state changes for a discrete event has no state changes between discrete time points that are recognized, while a continuous simulation does have an approximation by a discrete event system. Monte Carlo simulation, on the other hand, dates back to the 1940s, and a useful tool of the Monte Carlo simulation is to provide for some difficult integral estimation. And how it is applied usually is for definite multiple integrals in a mathematical physics problem, and is nowadays implemented in areas such as finance and statistical inference. To provide an example for a discrete event, we can see a bank where customers are coming in, getting serviced, and going out. Firstly, we look at the first customer who comes in. Since there is no one in front of him in line, he simply goes directly to the teller, does his business, and leaves the bank. Now, throughout the day, there will be customers coming in and out with waiting times coming up. So, for example, if we are looking at customer number N, he is coming in, noticing that there's a line in front of him. He will wait a certain amount of time before he's serviced, go up to be serviced, and then after a certain amount of service time, will leave the bank, exiting the queue. Now, some of the statistics that we can calculate in a discrete event simulation are the average wait time per customer, the average service time per customer that is getting serviced by the teller, and we can also look at different things such as the proportion of customers who had to wait before being serviced, where we saw the first customer not having to wait while the nth customer had to wait a certain amount of time. And then for each customer, we can see their total time in the system and find the average total time in the system for each customer. A continuous simulation can be seen through the calculation of gravitational effects on a certain amount of objects, and we'll call this n objects. Now, this simulation is using Euler's method, and for each object, there is an initial position for that object, x naught, as well as an initial velocity for each celestial body, which we'll see as an example here. And in this case, since it is a continuous simulation, we can choose an arbitrary time step h and see the exact position of every single object at that certain period of time. Then we can find the trajectory of each object and find where it is in space at a certain time period. In Monte Carlo, as I've said before, we can see that multiple distributions are included and can be pulled out so that with random number generation, we can solve to approximate an integral that otherwise would not be able to be solved, or would take a long time to mathematically solve. Now, for example, we can see below that there are multiple distributions. In this problem, we can see a binomial distribution as well as an exponential distribution. And knowing this, we can pull them out, use a random number generator that provides for us random binomial numbers or exponential numbers, and feed that into the equation to approximate what our expected value or expectation is, as well as the variance between the different simulations, and give a good approximation as well as a confidence interval for what we can foresee as the precise definite integral value. Now, just to look at a brief history of Monte Carlo, we know that it is a numerical method for statistical simulation, and what it will be using, as I've said before in our example, is random number generators. And what this does for us provides a simulation, as we can see on the picture of the right, in the case of the atom bomb. And that is actually the origin of Monte Carlo simulation, where we had a man named Newman who had his computers that were used, as well as Fermi, who was doing the physics calculations behind the atom bomb, and finally Ulam, who had the initial idea of Monte Carlo simulation after having much free time and being able to do things by hand and deciding to apply that to the new computer technology so that simulation could be done. Now, just to compare Monte Carlo with the other two types, we can see that Monte Carlo includes those random number parameters and also samples a statistical distribution, while discrete events provide a dynamic simulation following a specific timeline with discrete numbers in between used as integers. Continuous, on the other hand, provides for us a physical system which continuously tracks the response of a system according to a set of equations, and that typically involves some differential equations which make it difficult to solve, and Monte Carlo can contribute to that solving and is a very useful tool. Thank you for watching. See you in the next video.